So, it is just continue, this rain will continue and it goes to the next line CB, and it is observed that this D point is smaller than B. So, it will continue till D. Okay. So, you see after that generally you see whatever the value are there, you can observe that all are higher than D. So, here D is the smaller valley. So, as D is the smaller valley, that is why what happens here generally your rain will fall down. What I am telling, understand, because after that no support is there, that also you can observe. So, this is the first reversal you observe. So, first reversal is what? So, first reversal 1 is A, B, D, this is first reversal, what I am telling, understand. Then second case, what we need to consider? You need to consider second point, that is B point, that is the valley. So, in case of rain flow starting from valley, what we need to consider? Here the rain flow line will pass inside the pagoda line. So, it start from B and it goes to C point. After that you see it will stop at C. Why it will stop at C? Because, so this flow line will continue until it falls opposite a larger maximum point. So, you see it fall opposite a larger maximum point. So, as E is larger than C, that is why at C point here it will fall down, because you can say C is opposite of E. So, that is why it fall opposite of a larger peak. This you should keep it in mind, what I am telling, understand. It falls opposite a larger peak, or in case of what it is called valley, it fall opposite a smaller valley. These are the point you need to consider. Then in third case, the rain flow will start from second peak C. So, whenever the rain flow start from peak, there generally the rain flow line will continue outside of this pagoda line. You see it start from C and it will continue and you see just ahead of this line there is another rain flow line. So, second point you should keep it in mind. So, then the rain flow will stop here, that is why, because it will continue until it meets a previous flow falling from the above. So, as there is another flow falling line is there, that is ABD line, that is why it will stop in this B location, in this previous flow falling line. So, this CB is the next reversal. So, second reversal what we got, that is VC is the second reversal. Then third point is another reversal is, you can say CB, what I am telling, understand. This we should keep it in mind. The next you can say valley we need to consider. So, from valley once the rain flow start, the line will pass inside the pagoda line. So, it will continue to E. After E you see rest of the peak, that is G. After E there is rest peak G is lower than E. That is why what happens, this flow line will continue, and what happens after that it will continue and it will stop where, once it meet with a higher peak than E. So, as A is the higher peak, that is why here at A point it will fall down. So, next reversal which we observe, that is generally you can consider D, E DEA, this you should keep it in mind. Okay. DEA line you got. Now, this third reversal line, again we need to consider this peak A. So, from peak, once we start the rain flow line, then what happens, it will generally pass outside the pagoda line. So, from E it will continue to F. So, after F you see this H is you can say lower peak than F. So, it will continue to this what it is called, it will continue till H. So, after that you see no pagoda valley is there. So, from H it will fall down, it will fall after H, because no further peak or valley is not there, that is why it is fall down. So, this next reversal is you can consider E, F, H, this is another reversal. Reversal means half cycle, always you should keep it peak to valley, this is considered as half cycle. Now, next case we will start from the valley F. So, whenever it start from the valley, the line will pass inside the pagoda line. So, from F it started and it is continue. After that you see here at G point it will fall down. Why it at G point it will fall down? Because at G, after that A peak is there, A peak is higher peak than G. That is why what happened, at the G it will fall down, because it is according to point 1 you can say, because it will fall opposite a larger maximum point or larger peak point. So, it is this G is the opposite of A, that is why at this G it will fall down. So, next reversal we will start from the peak G. So, for peak generally once we start, then what happens, it will continue from outside the pagoda line, it will continue, and what happens, it meets with another rain flow line. So, that is why here it will stop. So, from G to along the line F it will stop. So, 6 you can say reversal we consider as G to F, G to F. Okay. So, the last reversal here what we need to consider, the last reversal is generally from valley H, it will start, when we will start from valley, then it will generally pass inside the pagoda line. So, it will continue, after that you see it meet with previous line, it meet with previous line. So, you see here it will stop, what I am telling you is here it will stop from you can say H to E. So, 7 pagoda line you can say H to E. Okay. So, this way generally we need to define the reversal. So, here this is generally reversal mean half cycle. Based on this half cycle we need to define the full cycle. How? Everything I will discuss in subsequent slide. So, here one things I have already written, this you need to note. The cycle which start at peak is shown outside the pagoda, and the cycle which start from the valley is shown inside the pagoda. This you should keep it in mind. Now, how to count this reversal cycle? This I am showing here by this table. So, here you see the first reversal which is from A to B to D. So, here what is the value of stress level or load level, that you can say. So, A has a value of a stress, let us it is -5, it is -5 is given from this, and here it is reach up to D, this first reversal it is up to D. So, it has a value of what? It has a value 4, this you should keep it in mind. So, this number of reversal, or you can say here I have written half cycle, that is a reversal I have written. So, full cycle will be two half cycle of same, you can say, range will be considered one full cycle, that I will just show. So, here you see, so ABD here it start from -5 and it stop at a stress level or strain level of 4 or load level, let it is 4. It means here you can say sigma amplitude equal to, you can say, sigma max minus sigma mean divided by 2. This you should keep it in mind. So, here generally range means here generally sigma max minus sigma mean is here it is considered. What is considered? Sigma max minus sigma mean. So, that is generally considered. If you consider its amplitude, amplitude actually this range divided by 2, you can say amplitude equal to, you can say this range divided by 2. So, range is actually here we consider sigma max minus sigma mean, this is range. What is mean? Mean is generally sigma m is equal to, you can say, sigma max plus sigma mean divided by 2. So, here range you can see which is actually sigma max minus sigma mean. So, here instead of range you can consider also amplitude. If you consider amplitude, this then this range divided by 2 you need to consider. So, range generally from where to where it is varying. So, range is sigma max minus sigma. So, here sigma max is 4, minimum is -5. If you just do it, then what happens? 4 minus, so here it will be like 4 minus -5. So, this will be 9, because 4 plus 5 it will be 9. Similarly, D2A, next it is a start folder, so D2A. So, D has a value which is 4 and its stop at A, another reversal, this is generally -5. So, D2A another reversal. So, this will have a range, that is 4 minus -5, this will give you 9, range value is 9. What is the mean value? Mean value will be this 4 plus, so here by using this equation you can find out the mean value. So, this will be -0.5, this also will be -0.5. Similarly, for BC reversal, you see from B to C, here it start from 1 and its end at -3. So, at BC you see it start from 1 and its end -3. So, in this case what is the range? Range will be 1 minus -3, it will be 4, and it will be mean value, that is actually 1 minus 3, that is -2 divided by 2, that is actually -1. Using this equation you can easily calculate. So, this way generally what we can do, we can easily find out what is the range and mean value for every reversal. After that, generally this reversal is half cycle. Now, we need to predict the full cycle. What are the number of full cycle of different range are there, that we need to find out. So, here you see, so what are the different number of full cycle range, like you see this range of 9 has 2 half cycle, you can see, that is A to D and D to A. This 2 half cycle makes 1 full cycle, that is why here number of full cycle in next table you can see, this 1 full cycle we got, that is A to D, it is started from -5 to 4, it has a range, same range data generally we need to add together. Based on these things we need to count the number of cycle. If this 9 range data have 4 number of set of data, then what happens here, the number of cycle will be 2. What I am telling, if it is 8, then it will be 4 number of cycle. These are the things you should keep it in mind. Similarly, this BC, you see this BC, this mean or you can say this range of 4 stress or strain data, range of this 4 stress or strain data has 2 set. This 2 set will make 1 cycle. This I have shown in table, this is table 2, this is table 1 and this is table 2. So, in table 2 you can say BC, this is started from 1 to minus 3 and it has a range 4 and it has a mean value also is given as minus 1. So, these are the information how many number of cycle of different range and different mean are there. This generally we used to calculate by using this rainfall flow counting method, which is generally used to predict the fatigue damage as well as fatigue life of a structure subjected to some haphazard types of loading. What I am telling, understand? So, this way generally first of all these are half cycle or stress reversal we calculate. From this stress reversal same range data we generally add together and we count the number of cycle, full cycle. This full cycle generally we need to use for predicting the fatigue damage, that is fatigue cumulative damage using Minard's equation or fatigue crack growth rate using what it is called fracture mechanics approach. What I am telling, understand? Now, another method, that is second method also is a very popular method for rainfall counting technique. What is this method? Explain. This method I am now going to explain. Let us consider a haphazard types of load signal. Here you see it is a stress signal. In this method we need not to rotate this stress signal with time. So, where generally we use the load signal horizontal axis as time axis and vertical axis as, you can say vertical axis as stress, strain or load load data. What I am telling, understand? So, for this generally how to plot the what is called rainflow reversal, that I am going to show. So, here the detailed steps is given. In this second method the analysis can be done without rotating the signal. Let us consider this is the example of stress versus time load data. So, here generally each flow began at the beginning of the time series. So, let us consider this here A, B, C, D, E, F, G, H, I, J, K, L. Let us consider this is M. So, let us consider these are the different peak and valley. So, in this case here one things you should keep it in mind, here generally peak is considered the top point, like here I have written. So, here the peak are B, D, F, H, J, L. These are all generally here we consider as peak, but in the previous method we consider once we rotate the things 90 degree, then this highest point was becoming the valley. This you should keep it in mind, but here we consider the peak point is as like whatever the peak value of the stress are there. What I am telling, under of different cycle. Now, what are the valley here? Here the valleys are like A, C, E, G, I, K, M. These are all valleys. These are the things you should keep it in mind. Okay. So, here what are the steps generally we used to follow, that I am going to discuss. So, here generally flow which is initiated from a peak, it continue to flow until it reaches opposite peak which has more positive than from a peak from where it started. What does it mean? This is one case. The second case, the flow initiated from a valley which will continues to flow until it reaches another valley which has more negative magnitude or more negative value than from a valley from where it started. This 2 point is very important point. What does it means, that I will explain, then it will be very clear to you. So, another next 2 point is similar to the previous method, like flow will stops where it meet any previous rain flow line. If there will be any previous rain flow line in front of the flow line, there it will stop. Okay. Then last point is flow must terminate at the end of the time series. That means, at the end of the time series where no signal is there, there flow will stop. Okay. So, here the horizontal length of each rain flow is counted as half cycle with that stress range. What does it mean? That also I will discuss. So, generally in first case we will start our rain flow from first valley A. So, this first valley we start. So, from valley which will be started, that will pass outside this signal line, and the flow which will start from the peak in this case, that will pass inside this stress signal. So, you see it start from A, and what happens here at B it will terminate. Why at B it will terminate? Because here one thing you should keep it in mind, here wherever it is started at A, you can say A valley is higher than C valley, because C valley is more negative than A. So, that is why it will fall where opposite to a valley, which value is more negative than the valley from where it is started. So, you see A have a magnitude which is let us 0. Now, this whereas C have a value which is minus 50, C value have a more negative value than A value, that is why it will stop where? It will stop in the peak B, which is opposite to this C. This you should keep it in mind. That means, it should not continue to flow towards C. If this C is if this is higher than this what is called A point, then what happens? This flow will continue. These are the things you should keep it in mind. So, this second point, this first what is called reversal case, this second point we are we use, because here what is the second point tell? Let us say flow started from a valley, it continue to flow until it reaches another valley, more negative than from a valley from where it started. So, you see C is more negative, C is you can say more negative than A, that is why it will stop at B peak. So, always you should keep it in mind. Generally a rain flow start from a valley, it will stop in a peak, it will go, that is one reversal. Valley to peak is one reversal, peak to valley is another reversal. So, this is the continuation of what it is called of a rain flow cycle or rain flow reversal. These are the things you should keep it in mind. As C is more negative than A, that is why it will fall from B. This is the things you should keep it in mind. The next case, the rain flow start from the peak B. So, it start from peak B and it continues to flow, here you see it is continue to flow and it goes towards D, as D is lower than B, that is why it will still continue, you see it will still continue, and you see it will still continue and it will goes up to what? Up to L, you see, because rest of the peak compared to B, rest of the peak D, F, H, J all are lower than B, but this L is more or less L is similar to B, that is why this line will continue up to what? This line will continue up to L. Here it will fall down, after L it will fall down. These are the things you should keep it in mind. So, always you should keep it in mind. In this case, in second case, you see you need to compare the peak value with next peak value. If the next peak value is higher than this initial peak value, then there it will stop. Higher, or you can say equal to, higher or equal to the next peak value, initial peak value, there it will stop. Like here, it will continue from B and it will stop where? Rest of the peak D, F, G, H has lower positive value than B. That is why what happens? It will continue to flow and it will terminate where? It will terminate up to point L. Why? At this L point, it is meeting a peak which is similar to B. If it is similar to B or higher than B peak, then also it will stop there. These are the things you should keep. So, this second case it follow this first point. These are the things you should keep it in mind. So, these 2 points you need to consider. So, here generally you can say this is the second peak, that is B, C, you can say L, and this first case generally you see A to B, this first reversal case A to B, this second point it is following what I am telling, understand. Now, we will start another valley point from C, because I have already told you from each peak and valley we need to draw the stress reversal. What I am telling you from C. So, whenever it starts from the valley, it will generally this line will pass outside the load signal line. So, it will continue, here you see it will continue, and at D point generally it will fall down. Why at D it will fall down? Because this opposite reversal E, which is more negative than C. That means, as E is, here I am writing, E is more negative than C valley, that is why at D peak generally it will fall down. So, C to D another reversal you observe. Now, from D peak generally the line will start, rain flow will start and it will pass inside the load signal line, you see, and it will terminate. Why it will terminate at C location, you can say at C line, because it meet with another rain flow line, that is why here it will stop, So, it will flow from D to up to C. Okay. These are the things you should keep it in mind. Now, next case we need to start from E valley. So, from E valley generally load line will be, that means rain flow line will be outside the signal line, it will continue, here you see. Now, you see it will continue and you see it will move, and where it will fall down? It will move like this. After that generally from L it will fall down. Why? You know, I have already explained, because you see generally from E, you see after E whatever the valley are there, this after this E, whatever the valley are there like G, H, K, all the valley you can say is less negative, or you can say all the valley is above E. That means E has a highest negative. What I am telling under, that is why this flow line continues and its fall outside the load signal line. where it's terminate. What I am telling, understand? These are the things you should keep it in mind. I have already explained these things. You see, if there is some valley point which is more negative than E, there it will terminate, or where another point is there, it will terminate where the load line stop. You see, there are no load signal after L, that is why here it will stop. Clear? These are the things you should keep it in mind. Now, next case, it will start from this peak F. Peak line generally its flow inside the load signal. You see, it continue, you see, it continue and it continue like this, and it's continue up to L. Because why it continue up to L? Because it start from F, after F whatever the next peak is there, that next peak is higher positive than F peak value. That is why here it is stopping, because after F generally L has the highest peak. What I am telling, understand? They are generally, so I have already explained these things. Generally where if it will be more positive from peak, if it will start, it will stop there where it is stop more positive than where it is from where it is started. What I am telling, understand? These are the things you should keep it in mind. Now, next value G we need to consider. From G generally the line will be outside, it will continue, you see. So, it will terminate at H. Why it will terminate at H? Because this I has a more negative value than G, that is why at H it will terminate. These are the things I have explained left side itself. So, you can easily draw this stress reversal. Now, again we need to start from H, because from E's peak and E's valley point we need to start the rain flow line. So, from H generally the line will be inside the load signal line. So, it will start from H, it will pass inside, after that it meet with another rain flow line. So, here it will terminate. What I am telling, understand? Here it will terminate, that you can say H to G up to G line. So, after that from valley I it will start. For this case the line will pass outside the load signal line, it will continue, you see, it will continue and it will go like this. You see, the next valley is, you see, above the I, that is why here it will not terminate, it will continue and it will go up to this. After that it meet with another rain flow line. So, there generally it will stop. What I am telling, understand? It will stop here. What I am telling, understand? Like this, this is point 1. So, it start from I, go to J. After that it is observed that K is above the I point. So, there it will not terminate, at J point it will not terminate, it will continue. After that it meet with a previous flow line, there generally it will establish point 1, there it will stop. Now, again it will start from the peak J, that line will be inside the signal line, it will continue. Okay. So, after that you see, after that you can see the next peak which L. So, as this next peak L is higher than J. So, after K generally it will terminate, after K this will drop down. What I am telling, understand? Now, from K again the load rain flow will start, which will be outside the signal line, it will start from K. After that it meet with another flow line, generally there it will stop. So, now from L generally you see this is the peak, here the rain flow line will start and it will continue up to m. After that you see no load is there, no you can say peak or valley is there. So, after m it will fall down. These are the things generally you need to consider, and you need to draw this way the different reversal line start from peak and valley. So, based on this different reversal line, you need to find out what is the range and what is the mean value of this reversal. Based on this mean value and what it is called range value, we need to finally find out the full cycle. How? That I am going to show in next slide. So, here you see, so this is the generally whatever the different reversal line I have shown. That first reversal line is you see, this is A, B, C, D, E, F, G, H, I, J, K, L, M. Already I have already shown in previous slide how to draw these things. So, first reversal you start from 0 to V, which has a value of 100 MPa. So, here the range is generally you know range, or you can say maximum minus minimum. So, range here always you should keep it in mind, range means sigma max minus sigma min. So, what is the range? That is generally putting, because this range we will use, same range we will add together and calculate the number of cycle for same range data, that I will show. Now, second reversal start from this 100 and it is continue, you see it is continue, this green line here I am showing here, this it is starting, it is continue and it is continue with a value whose value is minus 100. So, it is started from 100. So, that I am showing it is started, say next reversal it is started from 100 and it is stopped in minus 100. So, it has a range which is sigma max minus sigma min is 200, and its number of cycle means it is half cycle, or you can say it is half cycle, or you can say it is 1 reversal. This once you write it is reversal, this will consider as 1 as it is considered as a cycle, that is why it is 0.5 I have written. Okay. Now, the next cycle which is a start from C and is a stop from D. So, this C to D it has a value minus 50 to plus 50, you see it is started from minus 50 to plus 50. So, it has a range 100 and it has a cycle is 1 reversal, that is 0.5. Then D2 again it is a stop at C location. So, it is started from 50 and it stop at minus 50 stress cycle. So, it is started from here, you can see plus 50 it is started and it is stop at minus 50 and it has a range is 100 sigma max minus sigma min, it is another half reversal. So, next case you see from E, that is started from minus 100 and it is continue up to plus 100, you see E2, you can say let us consider the point is 2, E2 point L, actually it is instead of point 2, E2 point L, it is continuing this next cycle. E2 L means at the stress range varying from minus 100 to plus 100, here you see minus 100 to plus 100 and here the range is 200 and its cycle will be 0.5. Now, the next cycle which is started from F and which is stop, you see it started from this peak F and it is continue and stop at L, F to L. So, F to L, here what is the value of this thing? Here is at this F, it is a value is 75 megapascal. So, here you can see at F it is 75, it is falling after H. At this H, what is the value is there? It is also minus 75, it is also minus 75. That is why you see it is plus 75 to minus 75, it has a range 150 and its reversal means half cycle. What I am telling, understand? These are the things you should keep it in mind. This way generally which is started from ACE, it is terminated at you see ACE means it has a value 50 and terminated at G line has a 0 value. So, you see ACE is 50 and it is terminated at 0 value. So, it has a range you can see 50. Now, based on this range value we need to add this what is called cycle value which were given here. So, here you see this range 100, what is the 100 range is there, that first of all I am just calculating this 100 range, like this is 1, this is 2, this is 3, this is 4. So, 4 number of 100 range is there. So, 4 number of 100 range will makes how many cycle? 4 into 1 reversal means 0.5 cycle, it will be 2 cycle. So, that number of cycle, generally this 100 range have how many cycle? 2 cycle in this load cycle signal. Similarly, 50 range, how many number of cycle is there? 50 range is, this is your 1, 2, 3, 4. So, 4 number of 50 range data is there. So, 4 into 0.5 it will have what are how many number of cycle? 2 cycle is there. Then let us consider what is the 200 range, whatever the number of data is there, 2 number of range data is, this is 1, and this is another 1, what I am telling, understand. So, 2. So, 200 range data have 2 number of reversal, 2 number of reversal is 2 into 0.5. So, number of full cycle will be 1. Okay. Now, 150 range data, how many are there? This is 1, this is another one, 2 150 data is there. So, 2 150 data will create another 1 cycle. So, this way generally we can calculate the number of cycle. So interesting this method to calculate the what is called number of cycle, or you can say fatigue cycle of a haphazardly distributed load signal. Thus, this method, these two method you can, both the method you can use for rain flow counting purpose to calculate the stress cycle or load cycle, which will be generally further utilized in Minard's equation for cumulative fatigue damage calculation, or you can say which will be used for fracture mechanics approach for crack propagation purpose. Okay. So, this all about rain flow techniques. Next lecture I will discuss about Palmgren Minard's equation and how to find out the cumulative fatigue damage as well as fatigue life using Minard's equation or Minard's rule, that I will discuss. So, these are the references which I have followed for this lecture. Thank you.